Okay, everybody, welcome to Conceptual Physics. Today we're going to have a short video on how to do the math for the soccer punt lab. Okay, so this is math that you're all going to have to do. So make sure you're taking good notes here. So we have really, two pieces to this lab. The first one is we're going to drop a ball off the edge of the stairwell, and we're going to be able to time it as it drops. That's pretty crooked there, but we need to figure out how high this is. So I'm going to ask you to figure out how high the stairwell is. Okay, so let's just say that we time, and you have to time it with your phone. Let's just say that we time this drop for 3 seconds, okay? So we set up our little checklist. What's our V sub naught up here, you guys? Our V sub naught is 0 because, I drop it from a stop. Our final velocity, I don't know. My displacement is what I'm looking for. I don't know that. What's my acceleration? Well, it's little g in this case. And we're going to use -10. I know it's in lab, but we're going to use -10 anyway. Meters per second squared. And then my time is 3 seconds. Okay? So if I look at my formulas, I can use this simplified version of one of them to figure out my displacement. Okay? So x is displacement, and 1/2 my acceleration is little g, so it's -10. My time is 3, square that. So x is going to be equal to -5 times 9. So x then is equal to 45 meters. And it's negative because I start up here and I'm going in this direction, which is in the negative direction, especially since I determined negative direction by calling little g negative. Any questions on that? Okay, and so that's like, getting a distance or a height using gravity without having a measuring device. But now, so this lab, we're going to kick. So that's just kind of the warm up. This is the one that you're going to have to do 4 kicks because you have 4 kids in your group, 4 kicks, and you kick that ball and kick it as straight up as possible. What happens right up here? Stops and starts coming back around, right? So this will be the ball later. Now, you're going to have to take your phone out and time this. So let's just say that it was 4 seconds for the total kick. This is an important piece. What's special about up here again, you guys? What's the velocity at that point? 0. So that's kind of a special thing. And we're going to use that in this problem. So the question is, did it take all of 4 seconds to get to this high point? No, how many seconds did it take? 2, right? So the time to go up is 2 seconds. Time to go down is 2 seconds because we're starting and stopping at the same level right there. So that's an important one because you're not going to be able to, I don't want you to try to time when it stops and turns around, time the whole kick and then take half the time to do this math. Okay, so you're going to have to find 2 things. So I'm going to put our checklist in here. V sub naught, we don't know, but we do have to find that one. That's part of the lab. Final velocity, at this point, we do know. So we're going to use that because that simplifies our math a lot. If we were talking about final velocity down here, that would be the same as the velocity here, but in the opposite direction. Because everything up is the same as everything down, including velocities, times, distance, accelerations. So that would be the kind of harder math, but we're going to use this idea that we know that our velocity is 0 up here. We know that happens at half the time. So we're going to use that physics understanding. So our acceleration is little g. We can use -10 again. And our displacement is another thing that we want to find out. So here are two things you have to find out for the lab. So you have to do 8 math problems. And then our time to get to the top is 2 seconds. Keeping in mind, if we use the whole 4 seconds, this displacement would be 0. We want to know how high this thing went, so we're going to get to the half mark. Okay, so which one do you guys want to do first? Velocity or displacement? Okay, the vote was velocity. We could do either one first, but so we use our formula from last week. V equals V sub naught plus AT. Okay, so we know this V is 0 because it's at the top, and that equals the V sub naught is what we're looking for, and then it's a plus a negative 10 times 2 seconds. So if you screw anything up, it's going to be you putting in the full time instead of the half time. Okay, so 0 then equals V sub naught minus, because you're adding a positive or a negative number here, minus 20. Okay, so now to get V sub naught by itself, you have to add 20 to both sides, right? So then 20 meters per second is our initial velocity. Any questions on that? Okay, so it's not a question anymore. Now we know it's 20 meters per second. Okay, so now we can find our time a couple different ways. I'm going to just find it with this, or not our displacement, with this formula, the same one that we used in the beginning, right? Or that first problem. So this is going up to this point right here, and instead of having that the final velocity, we're calling that 0 the initial velocity, and then we're going to drop the ball because we know it takes, it takes 2 seconds to drop from that point, just like it would take 2 seconds to go up from that point, right? Especially, because it's starting and stopping in the same spot. So the reason why I'm going to imagine this is my initial velocity, even though my initial velocity happened up here, I'm going to use this as my initial velocity so I can use this more simple formula without initial velocity in it to find my displacement. So it's 1/2 times a negative 10 times 2 squared. So my displacement then is half of 10 is 5 times 4 is negative 20. Now, that's displacement from the top. But if I'm going to ask you how high, then you don't have a negative there. You just have 20 meters because that's how high the ball went. Okay, any questions on that? Okay, so that's the easiest way to do the math for the soccer punt lab. Keep in mind, this math is only straight up and down. When you guys kick, your kick is going to look like this. Unless you're really good, you could maybe get it to look like this. But we're just talking about how much time it goes up and down and the distance up and down. Even though there's velocity in this direction, it doesn't change what happens in this direction. Okay, hopefully this helps you complete the lab math. Okay, guys, have a fun time doing the lab.